Hello, so welcome back. So today I'll be teaching you how to make a blind assistance system with a real-time object detection module along with the distance calculation and voice alerts. I guess you have went through my blog. Yeah, I've explained it clearly over here. This is a detailed overview of the system. As you can see over here, this is the framework which we will be using. So if I explain you in simpler words, it will just be like a blind person will be having his Android phone. Into that Android phone, we are using a third-party open source application, namely DroidCam. So that for mobile phone will be capturing real-time images and will be sending it to a laptop-based server. That server will all the computations is taking place over the server system, uh, be it from processing of the image, voice generation, calculation of the distance. All the processing is done over the laptop system. Then after prediction of the exact class of that object along with distance and the alert based on distance, whether that object is too close or too far away from or far away from that person, it will generate an alert in voice module format, and it will be sent to that blind person through a wireless medium. So this is our framework. And we have used coco datasets, as you can see, that is common objects in context framework. If you want to know more about it, you can click on here and uh, you can get to know it. Okay, we have used TensorFlow APIs. It's a great work done by TensorFlow. They have already provided us with the object detection APIs. That means we did not here we are not focused on creating all such stuff from scratch. We are already having the benefit of with provided by TensorFlow. So without wasting much of the time, let's head on. We'll be using TensorFlow object detection API. So for that, you just need to click over this link. It will redirect you to the TensorFlow repository. Yeah. So you need to clone this repository and download it. This is the clone. Download zip. Okay. Okay. You need to save it as well. But I'll not download it because I already have it. I've downloaded it. Yes. Yes. So I'll show you the repository where it's downloaded. Yeah. This is the repository. Okay. So you can see that these are the same contents as here, right? So we just need to download this repository and make sure to change the name, because when you will download it, it will be named as, because when you will download it, it will be named as models masters. Okay, so you need to rename it to models. That make sure you are doing it. Okay, so we are done with the first step over here. We have downloaded the TensorFlow APIs. Now the installation part is quite simple. I guess if you are aware with pandas, or you have worked on NumPy or such similar stuffs, you can go with TensorFlow as well. You just need to put this command on an Anaconda prompt window. Now after that, these two steps we are done with it. Now we have to go for the Protobuf compilation. So Protobuf compilation is the thing which is for that for sure we'll be needing a Protobuf compiler as well. As you can see, when you will download the repository, it will contain a folder named as protos, and it will be having .protos extension file. We need to convert those .protos extension file to .py file to run it on our Anaconda system, right? Uh, so I'll show you first. Like, this is the repository provided by the TensorFlow. We are inside research now. We'll head on for object detection. Yeah, great. This is object detection. Inside this, search for protos. Yeah, this is protos. Yeah, so as you can see over here in protos, all the extension file are of .prototype, .proto. You can see, right? We need to convert this .proto extension file into .py file. And how we'll do it? Let's head on to my blog again. Yeah, so you can see we need to download first a Protobuf compiler. So I've mentioned the link. This is Google Protobuf releases. This is the same link. Okay, so we'll be redirected to over here. After that, choose one which is more relevant with your system, the one which most is most suitable with your working environment. Since I'm working on a Windows one, I'll go for Windows Win 64 bit operating system. You can know it as well, right? Just click on it, save it. It will get downloaded, but I won't do it because I've already done it. And if you want to know, you can go it here, Protobuf. You have to extract it, both the files in under the same folder. Yeah, inside Protobuf. Make sure and do one thing. When you download it, go to this bin folder and copy this path. You have to copy this path. Okay, now make sure this path is added in your environment variables, because when you will execute the command mentioned in my blog, when you execute this command, what will happen? If it is added already in the environment variable, it's okay, it will go with it. Otherwise, if it's not added, it will generate an error like protog is not recognized as an internal or external batch file. So for that, you need to make sure this path is added. So yeah, I'm again on my PC desktop. You just need to click on properties over here, go to this advanced system settings, click on environment variables. Now choose this path and make sure this path is added. So, see, I've already added the path. If you have not added, just paste it over here and boom, you'll be done with it. Otherwise, you need to paste it. I won't do it because I've already done it. Canceling all the procedures, you can do it with your system. Okay, so yeah, once you are done with it, we'll go for the Anaconda prompt over here. Yeah, this is Anaconda prompt. I usually have a habit of working under a environment by creating it. You can also do the same. Okay, great. I have not closed my caps lock. Conda activate my env. So yeah, it's actually great thing when you are working on a module. Such modules, make sure you are creating your own environment and then you are doing it, because you can do it in the base directory as well, but it will change other files in that base root directory. I usually prefer and recommend you as well create a environment and do it in it. Since I'll show you how to create, like conda create my this command will create a new environment for you, so you can code on it. Otherwise, just no issues, right? So this is my environment which I've created. So in this environment, I have to go inside that folder where my file is located. So cd desktop proj, inside proj there's models, then inside models there is research. I guess we have to go inside research only. Yeah, we have to go inside research only. So yeah, right now I'm in research folder. Okay, so yeah, we need to copy the command. Yeah, so this is the command which you need to copy. Since I'm on Windows, I'll copy this command. If you want to install it manually, the other links mentioned over here, you can follow this as well. uh, so yeah, I'll copy this command and I'll paste it over here. There, let me check, paste it out. I've pasted it and let's wait for the result. Okay, so yeah, object detection protos input reader dot proto has been converted. This is a warning, you can ignore it. Okay, that means resizer is unused, but still the work which we were aiming at, that is done. Let me show that to you. This is proj models research object detection. Yeah, this is object detection, and inside object detection protos. Cool. As you can see, this is proto file, the .py file for that. Py file, that means proto file extension has been converted to .py file extension as well. Great. So I guess now we are done with our establishment part, and I guess we are pretty much acquired with the libraries. After this, we'll head on for the model preparation, and the architecture which we'll be using over here is SSD architecture, that is single shot detection. It consists of a head and a backbone model, and its architecture, if I specifically talk about, then it's similar to ResNet. ResNet is, I've mentioned about ResNet as well. You can go over it, like it is almost similar to ResNet approach, right, for feature extraction. And apart, it's ResNet is a part of, you can see, if you compare it, the architecture which it uses, it is actually based on depth wise convolutions. Okay, so that was the concept behind that. But if I talk about its implementation part, we are using the single shot detection technique, and there are different models, other models as well. You can check it from my blog over here. You will be redirected to that Tensorflow directory repository. Yeah, you can see there are other various different models as well based on the Cocoa datasets, since we are aiming for the Cocoa datasets, and there are different speeds at which it gives accuracy. If I talk about specifically, this faster RCNN has the much higher accuracy speed, as you can see, and this is MAP, that stands for mean average precision. That means how accurate it predicts the class of the object. So this is the most dominant one, as you can see. its MAP, that means precision is quite high and the speed is also quite high. But I've used it and I'll recommend you, if your system is good enough, well enough, it supports GPU, you can go with it. But since I'm on a Predator, but still it's not supporting, I don't know. But okay, but it was showing a glitch in my in loading. So I went with SSD mobile net, or you can go with SSD Inception as well, or ResNet as well. They both are quite compatible with the system, and it will give you faster extraction, faster recognition, and precision is also quite good. So yeah, we are using this mobile net version. Okay, RCNN is also there. So yeah, you can go with it. So yeah, if you now comes the part of this. Yeah, I have mentioned of mobile net depth estimation. Since as you can see in the picture, it has mentioned like how the depth is being calculated. We have used certain codes that you will come to know in that module when we will be leading there. So yeah, now comes the part of source code. This is my repository. You can head on to this repository and you can open this code, webcam blind voice. Yeah, so yeah, this is the code. You have to download it and store it under the same directory. That means you have to store and download it under the same directory. That means in research. That means under research you have to go to object detection and you have to download it over here. Since I've already done it, I'll show it to you. So yeah, you have to download it from here. Let's download it and I'll show you. Yeah, so as you can see, it's downloaded and I've stored it under the same repository, same directory, object detection. This is the file, as you can see, webcam blind voice. Now you have to use any of the supported feature for coding. Either you can go with pandas or sorry, either you can go with spider or Jupyter. First, we'll go to an environment, panda, activate my env. Make sure you always work under the same environment. Now I'll head on with spider. You can go with Jupyter as well. So it's taking time for loading. Let's wait for that. Great. As you can see, I've already loaded this repository. You can say this directory. If you want to do it, you can go in the project, open project. Okay, you can go with this, or you can go in project, new project, select existing directory and choose the location of the directory from here. Like in desktop, it's under proj, this models, inside models research, and then object detection. You have to do this in the same way. I won't do it again because I've already done it. So I'll show you how the code is written. So now you have to go with for this webcam blind voice. This is the webcam blind voice. Okay, file. Now this is import numpy. So here what we are doing, we are actually importing certain libraries. Make sure you are done with the libraries installation part, otherwise it will give you errors. So if it's giving you the errors, I'll recommend sort it out either by searching it online, or you can say with the help of certain websites like Stack Overflow can be helpful for you in this terms. It will teach you a lot of stuff, or you can just install pip install pyttsx3. So these all are the libraries, I guess. You are pretty much aware with it. So I'll show you. Like you have to import numpy, this os and sys. These are for loading the files, joining the paths. Yeah, this url libraries for opening the urls. Okay, then we are having torch, pytorch, that is used for voice modules. Then we are importing engine. PyTesseract is useful for, you can say, for reading the text. Okay, so pyttsx3 is a great model. It converts the text to speech. It's Python's text to speech, so will be using Python text to speech library, and we are using creating the object inside this engine. We are loading the libraries over here, and the architecture which we'll be using is of ResNet type. Okay, we are opening the URL first and checking for a certain condition. If it's not accessible, it will if that it's appending the path over here, and if that is not accessible, it's actually going to this link, and it's linking it with the system. Now we are using the PyTesseract module, and the location of PyTesseract module I have shown it over here. You can put it with your location as well. Now the download base from where this model was about to get download. This was the download base for that. Make sure you have typed all the letters in the same format, because this is case sensitive. So make sure you are done with that. Now this is path to packets, and this is path to labels. So this is the same thing. You just need to follow the same stuff as I have mentioned in my code. So almost most of the stuffs I have done from my side, that is giving response with respect to my system, and this will hopefully it will give with your system as well. Total number of classes which we are importing, it's 90. Great. So since that's the beauty of Coco dataset, that means you can predict wide variety of classes of objects like bus, car, train, uh, person, bottle. So there are wide varieties of objects. You can go with it. Now we are having importing the model name along with their frozen graph inferences, and if that is not found, so it will first of all print it. It will print like downloading the model, and it will open that URL. Okay. After opening the URL, it will retrieve this from the download base, what we have mentioned over here, and it will append the model file as well. We have mentioned over here in above, and we are converting those into a tar inferences file, and it's searching for file in that tar file with its members with the help of this functionality get members, and it's joining its path with the base name into this file name type variable which we have created. So now it checks if that is already found, so it will print like model already exists, otherwise it will download and print download is completed. Okay. So yeah, now comes the part of the detection. That means for that we are using TensorFlow graph modules. So for with detection graph, we are importing it as a default type. Now with this graph def function, we are making it compatible with our TensorFlow and storing it inside a variable named odd graph def, and we are checking for this G file. Actually, initially it was giving me errors into my system. Make sure you are using the G file synonym with your desired TensorFlow version. I guess I'm using TensorFlow 2.0 latest one. That's why I've mentioned specified in this format. Otherwise, if you are having different one, you can go with your specified version. So yeah, great. We are using the G file as well. Now we are importing the labels map and categories map and category index. As you can see, these as this is the open source provided over open source project, कह सकते हैं framework. So I guess you're comfortable with it. So yeah, now we have mentioned the URL, and now after this we are using the concepts of computer vision and importing CV2. Yeah, and now for video capturing, we are storing it cap cv2.video capture. Since if you are using it with Droid Cam, make sure you are using the secondary source of camera, and if you are using the laptop's webcam, mention it as 0. Okay, so yeah, with now for the detection part, we are establishing a session that is graph detection session that we have created an object above, and we are naming it as says, and we are storing a variable name true inside this ret return type. And while that return type is true, it will read the image, and it will store under image underscore np, and it will wait for 20 seconds, or you can say that 20 milliseconds rather. This is milliseconds, this terms 20, it's stored in under milliseconds, and if a b is encountered, it will come out of the loop, otherwise it will write this stuffs. Okay, these are very basic computer vision libraries. Okay, now yeah, so we are done with that part. Now we are appending again this wget is that function which actually it gets to this link and stores it's under this os.system file. Now if you are using a gpu, so it will execute as with this function, otherwise it will go with this function, right? So it depends upon your system. Now we are evaluating a model with model.eval. Great. Then yeah, now we have to resize. As you know, deep neural networks, convolutional neural networks, it works better when it works better when the pixel values is between 0 to 1. As you know, like if in a normal image processing, basically in a normal image processing, an image has pixel values ranging from 0 to 255, right? Like 0, or you can say so we are using a filter to convert, because CNN based on such concept only, where we are using a filter, and that filter reduces this value from 0 to 255 into a certain value. So that is a different concept in CNN. So using the same terminologies, we are using the concept of normalize, and this values 0.485, 0.5456, 0.406 is actually, you can say, we got after a lot of hit and trial methods, and calculating is also, there's a different process for it, and explaining you that in this video is beyond the part of uh, beyond the scope of what we are doing right now. So let's head on directly for the object detection part. So yeah, this is for the categories, which we are going to this user content link and appending it in our system. Right now we are storing the list inside this variable classes, and we are opening it as class file and checking for it, right, in the strip version, and splitting it with the precision of 0 and 3, right? So this was the stuff over there. So now it will open the image and it will check for it, like if that image name is present, or you can say if it's among the things which on which our model is trained. It will predict if the model is, if the image which that person will be going and showing, if that is among the trained versions of the SSD model, so it will print this, otherwise it will go forward. I'll explain you, don't worry. And after checking, it will print that the possible scenes could be, right? And you know, as engine, we have converted it into, where I guess in above versions we have initialized that Python text to speech into engine, right? This Python text to speech is initialized in engine 1, so it will print this possible scenes maybe, and engine.say will predict it, right? So it's a great stuff that Python has. Now we are checking for I in range 0 to 5. It will check for the classes, right, and it will print the versions as per that. Now we'll explain you how this is it's working. So yeah, if the classes, as you can see, the class number 3, 6 and 8 is of truck, bus or car respectively. So yeah, if the classes are among this stuffs, and if the scores of them, that means precision score is, if it's greater than 50 percentage, it will go for calculating the distance. So you are calculating the mid x value and the mid y value, like boxes 0 I of +1, that means we are just calculating the average x value, average y value, and we are just rounding it with a precision of 1. And after rounding it off, we are on a scale of 1, we are storing the values, and we are calculating approximate distance, right? So yeah, and if that approximate distance is less than 0.5, so after, if it's less than 0.5, that means object is too close to him, so it will print messages warning vehicles approaching, and with the help of this engine.say, it will convert into a voice module. So it will run and wait for a certain time. Now similarly, we have done it for class number 44, that is of bottle, class number 1, that is of a person. Okay, so yeah, now if you press T, the OpenCV module or the camera which will be opening, that will get closed, and it will wait for this much amount of seconds. Okay, so yeah, it was a great stuff. Now we have to run the code, but I won't run it from here, because I'm using the same webcam from which I'm recording the video, so I have to record it manually with the help of a mobile phone. So I'll record it from the mobile phone, and I'll append the video after this. You can see it there. Okay, and apart, you can go and try, and if in case any kind of issues arises, or you can see if any kind of errors are there, you can post your comments in the comment section. I'll go through it and try to resolve your errors. Okay, so yeah, great. Now I'll be seeing the video.